Cramer's rule is a way for us to be able to solve a system of equations. Previously, we learned to either graph them, which doesn't help if your answers are not integers. Fractions, you just can't figure out what exactly the answer is on a graph when they're fractions. Substitution is one that we used also, but sometimes that can give you fractions when you're starting the problem. Elimination works also, and we've already discussed that. However, sometimes when you get a fraction as part of your answer, plugging the fraction back in can lead to some mistakes. So fractions can be a little bit difficult with those methods. Cramer's rule helps you solve a system of equations without having to worry too much about fractions. Oddly enough, it sets it up thinking of every answer as a fraction. All of your answers will be what we call rational, and rational, by definition, is a number that can be written as a fraction. So Cramer figured out that what we can do is look at every answer as a fraction. The x and the y coordinate of my answer have both a denominator and a numerator. So what we're going to do is we are going to set up three 2x2 determinants. The first determinant we call d, which also is going to stand for our denominator. This determinant is figured out by using the coefficients of x and y. 2, 3, 1, negative 1. 2, 3, 1, negative 1. So let's figure out the determinant of that. Remember, you multiply on the one diagonal, I get negative 2, minus, because I'm coming back the other way, 3. And negative 2 minus 3 is negative 5. I'm going to push this down just a tad. All right, so negative 5 is d. What I'm going to do is I'm going to put that, because that is my denominator, I'm going to write that in the denominator for both fractions. Now, I still need the numerator for x and the numerator for y. Those are my other two determinants, the first one of which I call dx. Now, I have not yet used this 8 and 2. So what I'm going to do is, for my next determinant, I'm going to look at the original, but I'm going to replace the x column with the 8 and the 2. So as you can see, I took out the two numbers that were the coefficients of the x, and I replaced them with the 8 and the 2. The y coordinates stayed the same. So let's find the determinant of dx. 8 times negative 1 is negative 8, minus 3 times 2 is 6, and negative 8 minus 6 is negative 14. That is the denominator, that is the numerator of x. So I'm going to put a negative 14 right there. All right, now I need the numerator for y. So what do I find? dy. dy is, go back to the beginning, I'm going to leave x alone, but I'm going to take that 8 and 2 and put it in place of the y column. So my x's are still 2 and 1, but my y's will now become 8 and 2. So when I find the determinant, I multiply those numbers and get 4 minus 8, which is negative 4. That is the numerator for y. For dy, I replace the y column, find the determinant, and my answer is the numerator of my y coordinate. So we should clean this up just a tad. And I can't leave a negative over a negative. That would not be appropriate. But do you see that I cannot reduce these fractions? 14 over 5, there's really nothing I can do, except knowing that the negatives cancel. So my final answer is 14 over 5, comma 4 over 5. Now, if I imagine putting a 14 over 5 in for x and then trying to solve, I can see some not so great work going on there, trying to work with the fraction, subtracting 14 over 5 from both sides. This one would be a little bit tougher. This gave me ugly answers, but no stress over it. All I had to do was cancel my two negative signs. That was no big deal. I didn't have to plug it in. although you can plug it in to make sure it works. Let's try one more from scratch. 5x minus y equals 16, and 2x plus 3y equals 3. So the very first thing I'm going to do is start with d. I need d, dx, and dy. d is the determinant made from the coefficients 5, negative 1, 2, 3. 5, negative 1, 2, 3. Find the determinant, and I get 15 minus negative 2, which is 15 plus 2, or 17. That's my denominator, so I'm going to put 17 right there. dx comes from replacing the x column with the 16 and 3. And then the y column stays the same, negative 1 and 3. 16 times 3, that would be 48. 48 minus a negative 3, which is 48 plus 3, or 51. 51 is dx. It goes in the x numerator. And now all I need is dy. dy is the determinant I find when I leave x alone and I put the 16 and 3 in the y column. And let's see what happens. 5 times 3 is 15, minus 16 times 2 is 32. And 15 minus 32 is a negative 17. So I'm going to put a negative 17 right here. So again, I have very strange fractions. However, I can simplify them in writing my final answer. Just so happens that 51 divided by 17 is 3. So I have a 3 here. Negative 17 divided by 17 is negative 1, and that's my final answer. I can check my work. I can plug a 3 in for x and a negative 1 for y. 2 times 3 is 6, plus 3 times negative 1 is negative 3. Does that add to 3? Yes, it does. And 5 times 3 is 15, minus negative 1. And 15 minus negative 1 is 16. So, yay, I have the right answer. All right, so that's Cramer's rule. Uses d, dx, dy to solve a system of equations. Good luck.